And let's do that. Let me just check the mic one more time. Okay. So it should be okay. Yeah. So a little bit about me. It's perfect to segue actually. So I was pre-pandemic. Well, I still do. I still love to travel. So I've been to 115 countries so far in about 45 of the states. And so the second part of career, a lot of my travel was going to remote places around the world and doing stuff like this, like just reaching out to underserved markets, starting up user groups, that type of stuff. It really caught on with SharePoint. So the SharePoint community had boomed to millions of people, over that time frame. It was pretty fun to be a part of. I think it was a coincidence too, like meaning it was right at the same time when social media was happening, right? So we had it a little bit easy. Now it's like you got to fight for everything, if you're trying to influence or do it, community or whatever they call it nowadays. But for us, it was a little bit different since we sort of started in the beginning. That stuff sort of lifted us, if you will. And so I still do quite a bit of that, more than most. I speak like I don't really travel that much when I'm telling this story. But I mean, just this year alone, I've been to 5 or 6 countries, around Asia. My first time to India in August, so that was neat. But anyway, going back to the group, so that's me. Oh, and just on the tech side, the reason why I'm here is so I have about 30 years engineering experience. I'm mostly, I started as a developer, and so I'm a dev at heart. That's where I feel most comfortable, although I spend most of my time now on the business side and building our team, et cetera. And I still am our key architect on the AI side. So how did this group start? Boss Hug, that's what we were starting before I started this stream. So what happened was the pandemic. I was flying all around the world, speaking at conferences and everything. All of a sudden, obviously we had the pandemic. And so I was like, well, gosh, what am I going to do now? Like, it was just shocked to me like everybody else, And so, I started this group remotely initially. I believe we did a couple of, we did start right at the beginning of the pandemic, after a little bit. And then we did remotely, and that's really what triggered it. And then we came back, not early, but we were one of the first once they said it was okay. Like once Microsoft was like, it's okay, then, we stepped up and it literally just started with 2 people. I think like it was me and you the first meeting, and 2 people went to 4 or 8. And now we can consistently get between 10 and 15 people, and good quality people too. Like I'm always impressed with the people that show up. Sometimes community user groups can be hit or miss, right? You don't know what to expect, but I feel like we always get a good group here. So you can hit the the QR code if you want to it'll bring you to a link tree, and then you can get all of the links for the group that we started. And essentially our mission is we try to dial into 3 and 8 on the world goals, which are the, good health and well-being, obviously, and then also decent work and economic growth. So we sort of see that as the 2 categories that we try to hit. And to get even more specific, I'm sorry, I pulled this actually from our company side. I apologize for our company name at the bottom. It's a slide that tells about our community stuff. So yeah, so goals. Oh, and then I would say that this year, though, we're refining our mission even more. Like we want to get very specific and see what we can do. For example, one idea we're tossing around is working closely with the clinical informatics groups and the AI groups at the local universities and getting them into more of the events. And I mean, we do that already, but we want to really try to formalize it and do even better this year with that. So that's sort of who we are in this spirit. And we do it basically like this. That's all we do is we just great speakers. We actually had somebody fly in at our last month's meeting. I forget where he flew in, I think from Chicago. And by the way, we do have a Chicago group too. So we're streaming. Chicago has like, I think 700 members. We have just over 3,000, here. And that's why we stream the events too. And so, yeah, that's what we do. We just get good speakers and show up and talk like this and share. And so this week, I'm the speaker, and as you know, the topic today is agents. Like really, just sort of. I'd like to hopefully demystify them a little bit by the end of the 1 hour. I mean, I know that's a tall order, but I think I can do it. And then I'd like to dive pretty deep. So I'd like to show you how we can do them in Copilot Studio, and then how you can use something called the Microsoft 365 Agents SDK. But then you can go down even a lower level where I really like, which is a semantic kernel, where you can actually write your own code and your own copilots and stuff like that. And before I start, how many people have worked with Copilot Studio yet and created a agent? It's pretty new, so I'm not surprised if not, if anybody has or anything. What's actually really interesting, I will admit this on the stream and everything, I have been talking about semantic kernel and agentic algorithms to programmers for almost 2 years now, and doing that mostly to Microsoft audiences. And today I built my first agent in Copilot Studio because I'm always usually doing it in VS Code. I've just never had time to go out there and check it out. But today I was like, you know what? I'm going to start this with a quick little demo of just how we even do this in Copilot Studio, just so you can sort of see what the agent looks like. And I think it will help too when we shift into code, because you'll understand a little bit more about how they're set up. And so with that said, it's a developer session, so we'll jump right into we'll start with a demo and we'll jump right into Copilot Studio. So you can go to copilotstudio.microsoft.com. You can do a 2-month trial. I think it's a 60-day trial that they have if you want to kick the tires on this. And then the plans are complicated. Please don't ask me too much about the plans, but I know like there's a $300 plan and then premium plans, etc. And so essentially in Copilot Studios, where it actually does several things, but our topic of conversation here today is agents. And so from a Microsoft 365 perspective and agents, this is essentially where you create your agents and manage them, etc. And so I actually created one earlier today. And actually, first, let me just show you what new agent looks like. So because I think you can see up front, one of the interesting things that they're doing is they're actually what I call eating your own dog food, meaning they're actually using a copilot to gather the information that they need to actually go behind the scenes and then generate the code for the copilot. So I want to give them a props for that, because I think that's a pretty big deal. And I can see it fixing a lot of issues and where you may have historically had user experience issues. So for example, here's a great one, dynamics, right? It's no secret that historically dynamics has just been very complex. The screens, the user experience, dynamics is Microsoft's ERP. And so, we're already seeing a bunch of copilots in dynamics that uncomplicate all that stuff, right? Because now you don't have to necessarily know where to drill down in Power Pages or, inside of dynamics. So that I just wanted to call that out. And there's a lot of demos on how you create this. So I don't want to spend too much time here, but it's basically, you tell it what kind of agent do you want. I said I want a snowboard agent. And then on the next screen, it asks a couple more. It's not gonna let me go forward. Let's give it a configure. Let's see. Here we go. I can just do this. It asks a couple more questions, like description, some instructions. And then what I can do is go ahead and add knowledge as well. And so in the case of my snowboard agent, if we just go back. So now let's go into the one I created. So I created this, maybe it took like, half an hour this morning, but it's basically a snowboard agent. And so what it'll do is I can ask it, what mountain should I go snowboarding at tomorrow? And so the knowledge it's going to use is I gave it a few URLs. I gave it one URL to the ski report website for New Hampshire, and then another one for the ski report for Vermont, because I also limited it to only give me advice about Vermont and New Hampshire. And then let me actually just go into so I can add additional knowledge stuff here. Sorry, just bear 1 second here. Okay, I thought I could find something easy really quickly, but I can't. So here, here's it. It's right in front of my face. The details. So here's the description. So this is an agent that compares Vermont, New Hampshire, and this is more or less what I typed in on the first screen. And then I gave it some instructions. I said, be concise in the responses. Just my personality. I don't like a lot of, I didn't want it to send me 3 pages of snow reports. And then I thought this would be fun. I said, use the tone and the style of Jeff Spicoli from Fast Times at Ridgemont High. So you remember Sean Penn, that he was the one there. And then compare the snow reports. And so that's sort of fun stuff, right? But now here's where we get into doing a little bit of the work. Compare the snow reports in Vermont and New Hampshire ski mountains, rank the results based on the best conditions for snowboarding, not necessarily skiing, for snowboarding. And then help book a hotel near the best option for a hotel. And then finally, check any severe weather alerts that might impact me, going to the mountain, just like, hey, there's going to be a huge storm tomorrow or something like that, which actually would make me want to go even more, but that's so that was it, and then essentially what you do is you answer those questions, and it got me to a point where, I could start testing the thing. And, as you would expect, I definitely don't want to give you the impression that this agent is perfect right now. Not by any means at all. Like when I first opened it and started testing it, I noticed things right away. Like, for example, it didn't seem to me it was being specific about snowboarding instead of skiing, right? So there's still some work here if I wanted to, really get this thing going and then publish it to various channels, etc. So, as you imagine, I can just, we'll type a quick thing here. What I should write tomorrow. And so this is where you can see it's starting to get into some of the agentic stuff. And so what I mean by it, you're going to understand that a lot more by the end of our meeting here today, but it's doing its work, right? It's going through in multiple steps, and okay, it did its, here's Spicoli, right? All right, dude, let's check out the snow reports. And then, of course, it queried Vermont, New Hampshire, and so it tells me, okay, J-Peak, which I agree with. I heard J-Peak actually has the most snow in the country right now, in the northeast of Vermont. Shred on, bro. And so that's it. That's agents at its most basic, at its most basic form, if you will. And so the idea with these agents are, again, is Copilot Studio coupled really closely with Microsoft 365. So it's pretty much, you can imagine, it's going to be primarily B2B, a lot of B2B, I'm sure some B2C. A lot of these agents you can publish in the channels. I got to give Microsoft props for this. They built on top of the bot framework. And at first that was a little bit, I found it problematic, but it's I think the benefits are starting to outweigh the pains, meaning, like, so for example, one of the things that they did really well historically are allow you to publish your bots to channels, right? So channels would be, for example, Facebook, Skype. Here you can see they've got new ones for a custom website, a demo website. And notice these are flagged for premium. And so they require a premium license if you want to actually publish this to, website, et cetera, et cetera. My expectation of this is I wouldn't expect this to be cheap. Like, this is built into Microsoft 365. Again, their bread and butter is the business corporate world, right? And that they're I'm not trying to imply that there's not great use cases for students and all that, but realistically, Microsoft's bread and butter, where they make most of their money, is in business software, B2B type software, et cetera.
Can you explain what the scanning of the sites, did you have to give it explicitly where to find the weather information? Or
I did, yeah.
Just scan for?
I did. So what I did, and again, because I wasn't necessarily I wasn't getting too fancy with it, and I don't even know if I can find the links right now, but I gave it 3 links. I don't know where I'd want to pull them up now, but the 3 links I gave. So first I did a quick search for, and I quickly found that there was a snow report site and that they had it for each state. and it will go 2 levels down and on the page for knowledge. So I gave it the top level for Vermont and the top level for New Hampshire. But then I wanted to give it some more snowboarding information as well. And again, I was in a rush. I was just doing this for a demo. So what I did is I found I asked ChatGPT, you know, top 10 snowboarding bulletin boards, and I found one in Reddit, group, and then I added that URL as well. So I gave it those 3 URLs to the agent.
Okay, and when you say 2 levels, it goes and scanned links and goes with those 2 levels.
Yeah.
Links? Okay.
Yep.
Nested
Exactly.
links. Okay.
Yep. Yeah. Exactly. And by the way, and you know, again, I'm not an expert with Copilot Studio. I'm much more comfortable with the code stuff that we'll dive into in a minute here. But it is worth acknowledging that you can add more additional knowledge as well. So that's what we could do on the knowledge tab here, and that should include uploading files, you know, as well. So let's just try it actually for goods. Yeah. So okay. Yeah. Well, so SharePoint Dataverse now. That's pretty cool. And so Dataverse is a data store for Power Platform. And then, of course, SharePoint, sites and document libraries, and public websites. Yeah.
Does not take image.
I haven't seen where you can add an image, but definitely check that, you know, Google Copilot, Ask AI or something like that. But I haven't seen where you would do that in Copilot Studio. So. But I do know they're using multimodal models behind the scenes. So they, you know, that they do stuff with it. As a matter of fact, one of the newest models that they just released last week that Satya he did a big announcement about, forgive me for not remembering the name right now, but it actually came out of the Boston Cambridge office. So yeah, so that's just for that. That's interesting to note as well. And that one is video. Sorry, that was my whole point. That one's video and imaging. Sorry, that was my whole point. Yeah, so it's a video model.
Sites, they have got live cams.
Yeah,
you could probably point that link to their site.
Sure.
Take a look.
Yeah, and I do suspect there will be a huge opportunity here. You know, if you were to ask me 2 months ago before DeepSeek, I was saying probably like, you know, a couple $1 trillion in the next 3 years just in B2B stuff, because realistically most AI so far has been B2C, right? It's been all like ChatGPT and public Perplexity, DeepSeek, like public facing, consumer facing AI. But now we're definitely diving into enterprise AI, like Microsoft finally ready. and they're really, but the good news is they're really ready. Like, and trust me, I would say if they were not, but things are like looking really, really good. I'm really impressed with the latest version of something I'm going to show you tonight, which is called the Semantic Kernel. So
the other thing that the agent was supposed to do is give you a recommendation, or how does that look like?
Yeah, and it did give me a recommendation, and candidly, that would be something that if I were to really create something like this for myself, I would want to go a little bit further and actually have it book the hotel for me and stuff too. Because otherwise, at a certain point, it's just like, well, what's the difference between this and just going to a travel site that's really set up nicely? You know, like it's got to really do some stuff for me. And actually, here's a great example of, you know, we're talking about agents now, and you're seeing your first example in Copilot Studio. And a term that you may or may not have heard yet is this concept of autonomous agents, right? Which are just agents that essentially run in the background. And which, by the way, it sounds really scary and people really like to hype that stuff. But really, at the end of the day, what we're talking about is orchestration of software objects. Like literally, like if you're doing this in C#, you are literally creating classes that represent software objects. And like it is seriously just data and code. And don't get me wrong, I'm not saying bad things can't happen. This is the way I think about it. A lot of folks don't know this, but I think it was the U.S. government, pretty sure, you can Google it, and Israeli security forces, they created this Sputnik virus. Remember this? Anybody in the room? So what they did is they wanted to cause some damage to the Iranian nuclear facilities or something like this, right? So they created a virus that would find those devices in that facility. And then what it did, forgive me if I get some of the story wrong, but I think what it did is it turned off the fan. So they would basically just overheat. And so what happened is it worked like a charm. Apparently the security guys were watching the TV cameras and because they got video surveillance, and all of a sudden these nuclear things just started popping off, boom, boom, boom. And it took them a long time to figure out what happened, and like months, maybe even longer. And so long story short, it was the Sputnik virus. But the problem is that they were so determined to get the target that it's a little gray, like what happened. But long story short, it went all around the world. Right? That was a Sputnik virus. It literally caused like billions of dollars. Well, I should put numbers. Thank you, Stuxnet. I don't know what it's called. So anyway, that is an interesting story, I think, because my assumption is that we'll probably have that 10 times worse potentially, right? But it's not going to be like Skynet where it's like literally coming down and hunting down, because people get crazy sometimes when they talk about this, you know? So I want to be clear, AI safety is so critical, right? And in my mind, like just being a computer scientist and knowing how viruses and bad things work on computers since day one with the computer, the PC, the internet, right? Mobile phones even now have viruses. My guess is that's the direction we really want to protect ourselves from, you know, really protect ourselves, you know, from that.
Can I ask a question about the kind of the definition of an agent? Because it seems like, you know, Amazon, AWS has their definition of what an agent is. I don't know if, is there an agreement what an agent is, or is just a bunch of API calls bunched together to do some tasks? Yeah,
it's a really great question. And I do think people might have slightly different definitions of what an agent is. But what's really cool is that is really solidifying now. And one of the links I'm sharing with you today, and this is up on the YouTube stream. I already had somebody on my team put it there. So right as soon as this meeting ends, the YouTube video will be there. And then these links will be underneath the YouTube video. So this I highly recommend. So this is AI Agents for Beginners class, 10 lessons to start off with just those basic things that you're talking about. Like even from the beginning, you know, what are agents and how do we build them? So for example, if I go into this, and what's really nice is it's actually a GitHub repo, and there's a ton of sample code in here as well. And they just start at the very beginning. Like you were saying, what is an agent, right? And so essentially the idea is that we're putting together code that has access to a large language model, can perform actions, access tools, and access knowledge. And it really is, like I said, I'm actually going to show you C# implementations tonight, but they literally are, you know, in the case of C#, if we're doing it with Semantic Kernel, these things literally look like classes and objects, and we're doing standard C# programming when we're building this stuff. So great question. And again, this link will be in YouTube, so you can dive into the, I'm actually even looking forward to going through it just to see what the most recent language is. And there's some new stuff as well that they've added around multi-agents, because once we start to understand the concept of using one agent, then we move into this concept of using multiple agents. And from a software engineering perspective, one of the things I would call out on this slide that's really important is the pattern that seems to be emerging is that you have this orchestration agent, if you will, that sort of oversees the other agents, especially if you're writing your own code. See, all that stuff will be hitting for you if you're using Copilot Studio. And really, a lot of it will be even if you're using the Microsoft 365 SDK, because the whole point of that stuff is to get you there quickly, right? But if you're building product or trying to invent something or build something, then obviously, or even enterprise software, right? You need to be an Azure AI developer. You need to put your Azure AI developer hat on, and how am I going to do Azure AI agents? And a lot of the times that won't necessarily include Microsoft 365. It really is the same old story, right? That story is not new. I mean, it's always been that way. Like if you want to do real quick business software, you know, going all the way back to Wizards, you know, in the early days of Office, right? And so historically, that this has always been the case, in my opinion.
But do I get the benefit of the scaling? So the threading, if I have to scan not 2 URLs like you did, but thousands,
yeah,
will it multi-thread it for me and give a thread to each scan that goes out and does everything in parallel?
Well, everything is a loaded term, but
well,
the stuff that we would care about as an AI developer, and it's certainly come a long way in the last couple of years. And I would just ask, I'm going to hold off on answering it with some slides and stuff, because that's really what the semantic kernel does for us. Like and I'll get to it in just one minute. We'll get there in just 1 second. Okay, so I'll make sure that, again, you remember to get those. Okay, and let's pull this up. This might even answer some questions as we go along. Okay, here's a better view. So the key thing here is that you have the orchestrator on the left. You have the user experience. This is key. The user experience is optional. What would we call this if we do not have a user experience? It would be an autonomous agent, working on definitions now. So if you have an agent that essentially can run on itself and it has no user experience, I would call that an autonomous agent. I'm pretty sure that's what the industry calls it. And then, autonomous agent. So then we have the knowledge, the skills, and then planning, exception, the autonomous part down at the bottom. And then you can see we can create multiple instances of the agent to the right. So when you're in Copilot Studio and you're creating an agent, the demo that I just showed you, it was a declarative agent, is what I'm trying to say. So in Copilot Studio right now, they have two different options. They have something called declarative agents, and they have something that's called custom agents. And the thing that's important to note is that if you do a declarative agent, to me, it feels a little bit like sort of the old bot stuff. And to me, if you use the word declarative in the context of agents, it's counterintuitive, because the whole point of agent is that you shouldn't have to declare what the agent's going to do, right? So just something to think about. So now when you go into Copilot Studio and you do your custom agent, I like to think of that as almost like agent as a service, where Microsoft is doing the orchestration underneath the scenes for me, so I don't have to worry about orchestration. It's handling a bunch of that stuff, and I'm customizing it using the agents SDK for Microsoft 365 and all of that, right? I'm customizing it. But at the end of the day, it's these are declarative agents. Sorry, I just lost my train of thought. So are there any questions before I move past this?
I'm curious, is there any can you name maybe one or two examples that people are actually using AI agents in production somewhere?
Yeah, that's a great question. I personally, other than the ones that we're building and we've just started testing, like I don't really know.
I've seen a lot of demos, but like
here's
actual like business.
Yeah, I personally, I don't know of any. Well, here's where it gets a little bit tricky. Is Microsoft just renamed what an agent is, right? So declarative agents, I'm sure there's lots of people using those, right? If that's what you're asking me, I'm sure they can provide you with many case studies and customer lists that are using Copilot Studio, and they're creating little widgets to automate. As a matter of fact, that one of the best use cases for this 100% in Microsoft, I think that it was actually smart. One of the first things they do is they basically put it right on top of the workflow stuff in the bot, because that's where you get the most value with modern AI, is with workflow and business process inside the corporate, inside the corporation. That's low hanging fruit, is you can just make all your workflows much better, right? So that I'm sure is happening a lot. I'm answering I'm the CEO and lead technical person for a startup. We're in Microsoft startups. We're building product. We spent almost 2 years now building a Copilot, and then Microsoft changed a lot of the language to agents. Thankfully, we were smart. We built our stuff on Semantic Kernel, and Microsoft, that's what ended up evolving as a way to do it. And that's what I'm going to show you as the next step of this. So if I were to answer the question in that context, I don't know personally yet of Microsoft partners that have some stuff out and deployed. Not to say it hasn't happened, they're not doing it. I just don't know of anybody. And it could just be because I'm so head down busy trying to get our stuff, out the door. So we don't need this. Okay, so then that's all. Everything I just showed you is Copilot Studio, and I showed you the introduction to agents. That was brand new courseware, by the way. Just literally came out last month, and literally was just published last week, like brand spanking new. It's like the latest messaging. I think they're preparing for Build. The Build conference is coming up for 2 months, so I'm guessing they're going to talk about a lot of this stuff at the big developer Build conference in a couple months. So everything that we talked about so far, building a custom engine, the declarative agents, that's all Microsoft 365 Copilot Studio land. And they do have one more thing that they give us, and that is they do provide an agent architecture as well. And they do this through the Microsoft 365 Agents SDK. So this is sort of one level lower now. So again, just for Copilot Studio, low code, no code. You want to start to do some integration with line of business systems, ServiceNow, maybe, and you want to control the code a little bit more. Then what you can do, and you're also planning on sticking inside Microsoft 365. That's a key thing. Then you've got the Microsoft 365 Agents SDK. That's like the next level down of customization for agents, where you get the next level of control. That's a GitHub repo. I may have it open to show to you, but if I don't, you can just do a quick search for Microsoft 365 Agents SDK and you'll find it. It's a GitHub repo. And so the SDK consists of access to Copilot Studio, Semantic Kernel, and Azure AI Foundry. So now we can start to talk about definitions a little bit further and dive in a little bit deeper. So let's pause on Semantic Kernel for a minute, because that's the first, it's popping up on the screen for the first time. So first of all, Semantic Kernel is an SDK. And actually, let me open up I already have it open. So first of all, it's an SDK. You can just type Microsoft Semantic Kernel and it'll bring you to the Microsoft Learn site. And there's also a GitHub repo. But essentially what this is, it's an SDK that will allow us to build on top of models from Azure Foundry. So Azure Foundry is the new name for Azure AI services. It's basically everything AI in Azure now is in Azure Foundry. And I think the only thing that's changed is the name since 6 months ago when it was called Azure AI Studio or whatever it was. So then, so Semantic Kernel. So again, it's an SDK and it allows us to build and integrate. It allows us to integrate business apps, but we can also build new apps. It's really sort of limitless. Here's the way I like to think about it. I just thought about this today, actually. When I look at the latest version of Semantic Kernel that we're looking at now, it reminds me of .NET 1.0. Because if you remember when .NET 1.0 came out, it was such a huge deal for Microsoft. They were all in. It was just like AI at the time. They were like, this is the most important thing. We have to lay down this framework. If we don't do this, and we're not going to be able to do anything else effectively. And especially, so effectively what they realized at the time is that they needed to unify their code base. Because what was happening is they were having to spit out a different code base for every version of Windows, different hardware platforms, different versions of Windows. And then the partners like me, we would have to do the same thing. And then people started adding in different OSs, right? And so all of a sudden you had to have it run on other people's OSs. And so that was the answer. It was .NET. It was like, okay, we're going to unify all of the software code libraries. It's going to be called .NET. And that's just the way it is. That went for 10 years. That was the first 10 years of my career. And I grew up in Burlington, Vermont, a small little town. There was one big company, and it was a software company. They invented the first healthcare software. That's how I got into healthcare software scheduling, program, if you will. So anyway, that was .NET. So now we fast forward almost 30 years late. Well, no, .NET was probably 20 years ago. And then we fast forward to today. And I would submit that Semantic Kernel really does the same thing for AI apps and agents and large language models. Like what it helps us to do is unify the code base, getting to your question about the definition. And even better, not only does it help us unify our code base across the LLMs, etc., but it provides services. So for example, we'll start talking about some of this stuff, state management, you know, how do I track what the user is doing or the questions they're asking, those types of things. And that's our introduction to Semantic Kernel. And of course, we'll continue to dive deeper into that. As a matter of fact, I want to go through these slides a little bit quick now because I really want to start showing some. Okay, here, let's go. So that was all Microsoft 365 agent. Now we're going into more of what I would call AI dev, Azure AI dev. Everything we're looking at now, none of it requires Microsoft 365. You can do all this in Azure. I actually have in this machine, I actually even have an LLM running locally. And we can take a quick look at that and how you can even, so you not only do you not need Microsoft 365, you could do this stuff locally on your laptop. So, which is pretty interesting. Okay, so Semantic Kernel. Lightweight, open source, key, production ready, orchestration middleware that lets you easily add AI to your apps. Another key thing to note is that it supports Python, .NET, and Java. It seems like they release all the Python and .NET stuff at the same exact time, and I've noticed the Java stuff is just lagging a little bit in the SDK. So Semantic Kernel is you know, essentially at the center of it all. So it's it allows us to, it's responsible for orchestration. Let's just first acknowledge that. But it also allows us to create, one of my favorite features is it allows us to create plugins. And actually, even to be even more specific, my favorite plugins that I can create with Semantic Kernel are using C# and then they're called native plugin functions. And so it's literally compiled C code that can run as a plugin. So it's just super fast performance for your middle tier.
When you say plugin, is plugin for what?
A plugin is
Microsoft product?
No, it's not. It's a standard.
In a browser plugin?
No, it's like, I think I have them here, don't I? I have them turned off? Shoot. Okay. No, here we go. Plugins. So it's sort of like browser plugins, but for AI. They're the widgets. You know, they're widgets that you can use with AI. So sort of like an agent. They came out before agents. And by the way, a little bit of the history on agents. Like technically, what happened is OpenAI came out. Then what happened was right away, LangChain was the one. Really, I call them the godfather of reasoning, because they were the ones that really started all this. Like, I don't know if you remember, but like 2 years ago, there was that news story that came out. And it was like, oh no, now it can do its own thing, right? Blah, blah, blah. And that was LangChain. They basically, what they were doing is like talking to the LLM and asking it to figure out what function to call. But it turns out that's actually really powerful, you know? So right after LangChain was released, then what happened is Microsoft released something called AutoGen. And AutoGen was their flavor of LangChain. And it was just lightweight reasoning. They didn't even call it reasoning at the time. It was like, I forget the term they used. And then what happened is they released Semantic Kernel shortly after that evolved into an SDK that includes, by the way, sometimes another way to think of the reasoning stuff is orchestration. Like, a lot of that happens at the orchestration level, and I'll explain that. We'll continue to look at some code and stuff. But this is what a plugin is. And by the way, this is the app that I'm choosing to demo for you today. So this is built using Semantic Kernel. So what you're looking at right now, you're looking at a JavaScript front end, and then we have our middle tiers written in C# that's running Semantic Kernel, and then we connect to for the demo environments. I don't forget exactly what model. I think it's just a standard GPT-4 in Azure Foundry services. And so this is you know, real app multi-tier that I have up on my dev machine. This is my actual dev machine. And so that's worth noting, because that's some of the code that we're going to start looking at here. As a matter of fact, I'm going to start doing that now just because of the time. So, well, let me just check one more thing. let me just show just a couple more things because these are important. So it literally is a .NET thing. So see in the middle, why isn't it not showing it? Okay, like you refer to it, is in the namespace is Microsoft.Semantic Kernel, and then underneath Semantic Kernel, they just added a new namespace for agents. So now there's agents under there. So see how it's starting to completely build out and how it will bring together the LLMs and agent code, etc. And then you can see they've got the Microsoft extensions for vector data are used by Semantic Kernel memory. So this is going to get, it's not terribly deep, but it's an important thing to understand, and it helps to illustrate some of the things we have to think about as we go forward and why the semantic kernel is important. So what I mean by that is if you look at any standard, AI chat interface, like for example, the one that I just showed up, I pulled up here, when we're talking about memories, it's this stuff on the left, right? Like when you're using Perplexity and ChatGPT, it's those saved chats, right? And if you think about it, when you're using your favorite AI, whether it's Perplexity, Chat, they all work the same, but you could go back to that conversation, you could pick that conversation up again, okay? So now if you think about it, and historically, the way we would do that building web apps in .NET is we would track that state through web pages, right? If you think if there's the most basic example, web pages. And if you think of hello world, and you pass the value between two web pages, typically you might store it as a cookie, right? And it would be a key value pair, like name equals Paul, something like that, right? And then you go to page 2 and you read name equals Paul. Key value pairs, that's the way we've done it historically today. We can't necessarily do that anymore because now the data is represented in the vector format. And we need to be able to access it through code, and we need to be able to, semantic format. Sorry, I misspoke. And then also in vector, but the word I was looking for is semantic. The key difference being is that we're no longer talking about key value pairs, right? The thread could be an entire conversation history, if not more. And now they're even getting more sophisticated. If you look at ChatGPT now, it actually saves all of its memories about you. There's actually a tab now called memories. I don't know if you've seen this or not, but when you click on that memories tab, it'll show you all of your previous chats and everything it knows about you. Like for example, I was testing it a couple weeks ago and I was like, hey, I'm Paul Swider, I'm this, remember this. And then sure enough, it remembered it and it filed onto those memories. So that I would refer to as application state, right? That's the state of our application. That's the stuff that we need to learn how to deal with as AI developers in Azure. That is another key thing that Semantic Kernel does for it. It manages a lot of that stuff underneath the scenes for us. We could write all that code ourselves, and there's different frameworks for doing it. There's a lot of open source frameworks. Semantic Kernel is open source. But one big advantage of using something like the Semantic Kernel is memory management. Okay, questions?
So you mentioned LangChain. LangChain is a good example of retaining the context of a multiple chat sessions, right?
Yep.
And that allows us to connect those variety of questions and be able to ask a follow-up question and retain
I'm listening
the
to you. I'm just going to pull something up while you're talking. Yep, go ahead.
Do you associate that to the capabilities of an agent, or this is just basic capability of LangChain,
No.
our ability to understand the context and retain that? Something's giving me that service right now, or I write it myself.
Yeah. The best example to see this is Perplexity. If you're using Perplexity, you can attach to DeepSeek in Perplexity, and DeepSeek has it's the easiest to see the reasoning and how it's working. They just do a really good job of telling you. They show you how it's working.
Yeah, they basically run a search, get the result, they feed it, get the response back. They do multiple things in front of your eyes, right?
And guess how they do it? I don't know for sure, but I know they're a Microsoft partner, and I know they build on top of Microsoft. I'm pretty sure the Semantic Kernel is probably under there somewhere for Perplexity, right? I know it is for us.
I thought they have a large investment from AWS, so they might be using
Yeah, let's not go there. You could be right. I shouldn't say things that I don't know for sure, but the
okay.
point still stands, right? That the point still stands. So let's bring this back home though. So you can see it in ChatGPT Pro too, right? Like I can say, I hate to waste the GPU on this, but like, you know, give me ideas for a weekend. Okay. But the thing is, you have to click on details. And when you click on details, as soon as it gets ready, and by the way, this is so painful. I don't know if you've tried this yet. This is the $200 a month version. And it does a good job, but it takes like, sometimes it'll literally take like 10 or 20 minutes. And honestly, I don't even think it has to. Like, I think they're doing stuff behind it to make me think it's worth the, I don't know. I wonder sometimes.
If you had a more specific question, would it?
No, because I've been testing it a lot in the last couple of weeks.
You know,
So, but it's worth it if you really do have something complex, right? Like if you're trying to figure out, you know, okay, I've got this proposal, how can I make it better than everybody, that type of thing.
Yeah.
Then, and I have some stuff I want to give it. Well, then it's worth it. I'll type out a prompt and I don't care. I'll go get a coffee and it really is that good. Like it comes back and it's because of the reasoning. And that's, I don't know why it didn't reason here. It didn't show any details. But, sorry.
I just wonder if the reason for this slowness is this is their mechanism for making sure you don't burn too much CPU.
It could be very complex. You know, I remember at one point hearing that part of the success of ChatGPT was that they actually purposely delayed what was coming back. So it sounded like it was, you know, speaking more or less, right? Because technically they could just dump it all out to the screen, or at least big chunks of it, right? You get a huge chunk right back. You could just go boom, right to the screen. But no, I thought it was actually pretty brilliant. One of the things they did was just slow down the output of the characters, and then it just makes it seamless. And so that's what I'm getting at. Like, I don't think that's all that's happening here, but I wonder if it might be a little bit, you know, with the longer thinking. So that's reasoning.
Deep research? Yeah. Have you tried using deep research?
Which one is deep research? Are you talking about
the toggle, like what it does deep research?
Oh, yeah. And you know,
I'm using that a lot.
you know what? That's probably what I forgot to do, and that's why it didn't do the research, right?
Yeah.
One of the things that took me a little bit longer to ask questions and parse output from web was that you don't really know how big, and you have to do the chunking and all that. So then you get to, you know, I wouldn't say I wouldn't wait minutes, but I would see reaction time in like 5 seconds rather than split second.
Yeah. So this was taking a little longer. Now, I'm not going to do this again, and I'm going to push things along. We can come back to this screen if we want, but I'd rather just show you some more code for Semantic Kernel.
Oh, I think it was asking a follow-up.
Oh, was it? Okay.
Because deep research, what sometimes does is it.
What kind of? Oh, okay, gotcha.
So what is the difference between what you had done and then using the deep research? What does it provide you?
I think the deep research is what actually turns on the reasoning. But we'll see. We're testing it now.
And it gives you all of it?
Yeah, see here, starting. Yeah, and we should see details on the right as it starts the research.
It should show the sources.
It shows the sources.
Yeah. I'll come back to this, but while we're waiting, there's something called Ollama and LM Studio, and these will allow you to run LLMs locally on your laptop. You don't even need a GPU. So if you just want to play around, etc., or you want to write some local code, and I actually have a version running here in the background. This one is. Now, see, when you install it this way, though, you don't have a nice GUI for the chat. You can only test it through PowerShell. Now, you can download GUIs to put on top of this, you know, and play with it more. But just while we're waiting, I'm just trying to give you as much information as possible. But these are the tools you want to look at if you want to do this disconnected from the internet. We're working on that right now. It's important to us because we work with really sensitive data sometimes. And also we work in environments where they're just frankly not ready to take a huge jump with data and AI. And so what's important for us, what we're working on right now is reasoning, but doing it locally with a local model. And so our first round of testing that we're doing is with DeepSeek. And so the idea is that, remember that slide that I showed you with Semantic Kernel, and there's always a big orchestration piece in the middle. Well, the idea is that we would use DeepSeek reasoning for our orchestration, or at least that's what we're going to test, you know, for part of the application. And it's a little slow, you know. It's been open for a few days, and so it probably had to start itself up again. But you see, it gave the response back.
So this is the Llama 2 version of the open source?
Yeah, I think I installed.
Did you modify it?
It's this one right here, Run Llama 2. And by the way, the whole thing is, what is it? 3.8 gigabytes, right? Which is essentially the weights. So this is a little bit weird. I want to run this by some people. So far, nobody's giving me too much pushback. But to me, it almost sounds like a zip file. You know, like, remember back in the days when like computers were a little bit slower and you say, hey, I only want to zip the Z drive, and then you'd have to go away for the weekend and it would be back Monday. And really, it was just taking everything on the Z drive and just putting it in a much more smaller format. Of course, you couldn't access it, right? That inference, right? So we have to come up with a way to inference that data. That's what inferencing is, right? If you think about it from an AI perspective. So I would submit one real easy way to look at this from a software architecture perspective, if you don't want to get all bogged down and, you know, crazy stuff, is just to think of that 3.8 gigabytes as essentially, you know, a massive compression of information, right? And then what we're doing is we're inferencing against that thing to do useful stuff with it, right? One of the first things that we see is chat completion, right? And it's literally called that in Semantic Kernel. So if you don't mind, if we just jump into the code again real quick, because we're running out of time here. Here's the reasoning, by the way, just look real quick. So see over here how it's going through. Look at all this reasoning. So first it's looking near Boston, and then it's like, okay, go on the snow, and then reading these. Yeah, it just goes on and on, right? And then down here it does it, then it finally, actually it's still doing it. And then eventually it will aggregate. It does all this stuff, and then it'll aggregate it. It's actually really good, actually. Yeah, exactly. And I like to show it during this demo because that is what we're talking about here. Like that is, I call it agentic. They're agentic algorithms. You can call it agents, this, that, right? But at the end of the day, what I call it is it's agentic algorithms, right? And that's what's being represented here. So if we look at just a little bit more of the code, just first let me refresh your memory. The front end is in it's JavaScript, it's in VS Code. And what I'm showing you here is this is not the front end though. Sorry, I tricked you. I'm actually showing you the back end through VS Code. But the reason why I have this pulled up is this is how it all starts. Like you create a kernel, literally, kernel.create builder. And then what you do is you add what AI services you want to use in your kernel. One of the very first AI services you might want to use, especially if you're doing chat, is the chat completion service. So see here how I have add Azure OpenAI chat completion, boom, right? And I'll give you another tip. So then the other cool thing about Semantic Kernel is you can actually create a custom connector to connect to other large language models. They have a couple out of the box that they give you. But for example, right away, I want to connect to DeepSeek because, again, remember my use case. I want to test reasoning with DeepSeek through this code. So the only way for me to do that is I have to now create a custom provider inside the semantic kernel. But, you know, the cool thing is it's not that hard now with AI. You know, back in the day, you'd be like, oh, man, I'm not no fun time this weekend. You know, it's going to take me a week to write this thing. But no, I just went into ChatGPT, the code mode, you know, and you know, hey, here's my stuff so far. Now I want to talk to DeepSeek, you know, help me with a connector, right? And, you know, as you know, it's 100% perfect, but wow, it's like, oh, okay, I definitely see what I need to do, you know, and then I can flush out the code.
But they charge you by the token.
Well, the usage here, but when I switch this where I'm using DeepSeek locally, no, it's open source software running on MIT license, and I don't have to pay any fees.
Use it locally, but if you wanted to use what they provide,
Azure Foundry,
you're paying the Azure price per model.
It's called the Azure AI Foundry, and that's where they have all their AI models. Now, I'm sure you've heard of it, and including some new healthcare models that they just added up there this week. Yeah, super cool. By the way, I added a link to a Microsoft research event that happened this week in healthcare, and they talked about some of these newest models that they just released in Foundry services.
And they disclose the content that they retrain it on?
I didn't dig into all of the models in that much detail. I actually got sidetracked and I started looking at one. I don't even think it's new. It's just a newer version. It's called Chimera, and it's used actually for molecule discovery and figure out molecules. But then once you can do that, then you can do drug discovery and different things. And so I'm interested in that also because one of my friends at the gym he's pretty high up in applied materials. You know, they make the chips for the AI and stuff.
Yeah.
And so he's always asking me, you know, like, how can we, because Microsoft used that model to find a new battery. I don't know if you remember that. That was the news 9 months ago, right? So actually, that was one of the tests I did with the deep reasoning. So I put all that stuff in there. I by the way, when I do this, I usually use 2 or 3 AIs. Like I might start in Perplexity and get stuff, and then I'll put all that in like the Pro version and let it chug on it. And that was one of the tests I gave it. I said, hey, tell me exactly how applied materials could benefit from this model. Like, and it gave some great examples. I emailed it to him. I saw him this morning. He hadn't seen it yet, so I can't say that it did a good job yet. I I want to hear from him, but that gives you a sense of some of the cool stuff you can do, right? That's not even the space I'm in, but I'm like, wow, this is just sort of so easy now. You know, you connect a model, and you know, like I said, even in the old days, if you had to do a custom connector, I can't remember how many wasted weekends I've had in my past where I was trying to troubleshoot connectors to different things. But yeah, so I don't know if we can cover a lot more because we're going to end in 3 minutes here, and it's just such a broad range, broad topic. But my goal was to demystify it at least a little bit by the end of the meeting. And I think what I would do is summarize just by reminding you that today we reviewed agents from a Microsoft perspective primarily. I say primarily because Semantic Kernel is open source. It's by Microsoft. It's open source. And then so we looked at Copilot Studio, and we just acknowledged that that's the really quick, fast way to just get some stuff going inside your organization, make workflows better, speed up processes, etc. Low-hanging fruit. And then when you need to go down one more level and start customizing this stuff with Microsoft 365 and your line of business apps, all that good stuff, then you've got the Agent SDK framework, Microsoft SDK, Agent SDK framework. And then finally, you go down one level more, then you've got the Semantic Kernel SDK. There is something else called AutoGen. AutoGen is that's, again, they introduced it right after LangChain. It was like literally their very first answer to LangChain, but it has evolved actually quite a bit, and it can stand by itself and do reasoning. So yep, have to mention AutoGen. And so that's my summary. And so now I'll pause. We have like 2 minutes for questions. We've been asking questions along this. It's been conversation.
I've been asking a lot.
That's okay. Great questions.
Quickly, then.
Yeah.
If you notice, like the reasoning, there's some problems.
Yeah.
Could you change something to so that you train it so that it will not repeat the same?
Yeah, great question. Here's a great. I like to show this. Notice down here we have the prompt suggestions, and you've probably seen this with the Microsoft apps as well. The whole reason why we do this is a little trick that I've learned to help. Well, I figured out what I think why Microsoft is doing it is because what this helps me do is to be a lot more accurate in my code where it's calling the functions. So what do I mean by that? If we actually go into the code, hold on just a second here, the web API, plugins.
So those are suggested prompts.
Real activity. Okay, here's some sample stuff. Okay, so this is a semantic function. What makes it semantic is it's tagged right there. See, it says kernel function. It's got the attribute at the front. It's tagged a kernel function. That tells .NET it's a kernel function, and it goes off. It's semantic kernel. And what that means is that semantic kernel is going to be responsible for calling it. And the information it has to go on is the description. And so the trick that I use to get better accuracy in the orchestration and calling the right function, the one trick is that you can select the exact prompt, and then I match that prompt to the description here. It's literally an exact match. And so you get just a much better percentage. And also update you're to the latest version of AutoGen. Make sure you're always updating to the latest version of Semantic Kernel, because the reasoning and orchestration will continue to get better and better and better. I've already noticed massive improvements. So.
I like that you're very hands-on. You just go to the code and you don't.
Yeah,
I don't care.
Yeah, no, I live and breathe this stuff, so I love it. I properly introduced myself, developer at heart. Yeah. But thanks, I take that as a compliment. Thank you. And this really is the heart of it. This is what's happening behind the scenes. Like when we're looking at ChatGPT and it's doing that reasoning in the sidebar, what's happening is the large language model is looking at the input from something. Maybe it's the chat. It's me, right? I select that prompt and then I give it a doctor's name. That's the input. So then the input comes in here, and then what it does is it uses a large language model and it looks at all the functions that it knows about. It looks at all the descriptions and it says, oh, okay, which one should I call? See, that's huge if you think about it, because that means for the first time in my lifetime, we don't have to do declarative programming. So sometimes I like to annoy my AI, like the ones that are really deep into it and stuff, and I'll just I'd like to remind them that it's just code and data at the end of the day. And I strayed a little bit. I forgot where I was going with that. I should stop talking. Especially since I'm on camera.
Does it actually vectorize our prompts in a way that then does the search?
It has to. The semantic kernel will take care of that for you. Okay. But yeah, I mean, if it wasn't for semantic kernel, then you would have to handle a lot of that stuff. And in the early days, you did have to handle a lot more of it.
Yeah, did it go? I mean, the algorithm went and got kind of recursive about each word in your sentence, but I think now it's like bunched up as the entire prompt.
Yep.
Is served as a vector, and then the search for the nearest neighbor or something.
Yeah, I mean, it gets back to that, what I call a fancy zip file. I mean, at the end of the day, you know, you're pulling in a bunch of data, and instead of storing it one way mathematically, now they're using vector math, right? And so it sounds to me that's sort of like almost like quantum, that when you do that, now you can save things, you can save exponentially more stuff, right? Because you just opened up all your you have a lot more planes, right, to store stuff, right?
I always imagine it as like a set of tensors or...
no, it literally is just a vector. It literally is just a vector function math. Like, I mean, it literally is just that. As a matter of fact, if you were to look at the weights, that file, it's literally a CSV file with data in it. Literally is what it is.
But
is
that the representation of what we... If you had to draw it up, you'd say, okay, here's my... first layer of the neural network, and I got maybe 10 cells. The next one I have 200, and the third one I have 500, and so on. And then there's kind of n dimensions, which is represented by the vector with the values. And then, so it's kind of traversing that vector across this big tensor.
The short answer to your question is that's more or less a lot of the stuff that the transformer will handle, right? And it's also inferencing. So you're getting, but we just can't cover it in this meeting. It's just way too much, a whole nother meeting. But once you have, let's just say, the fancy zip file or the model, the language model, right? That's only part of it, because then you have to figure out how can you inference it. And not only that, how can you inference it at scale? And that gets back to an earlier question you had, like, can this stuff scale? If we, as you noted with Semantic Kernel, it's flagged as enterprise ready. Microsoft won't make any breaking changes. And so, you know, they help on the scale side as well. But really what you're getting into now is tokenization, inferencing, and how, like, once you get the initial response back, which is going to not look anything readable, then how are you going to transform that and then, you know, do something useful? Then what the next step is they write tokenizers, and then they take that useful stuff and they do go through a tokenization process and send it back out. But again, that's a whole nother meeting. So I'm not going to take it. I'm not going to take questions, but it's that stuff. Yeah. Okay, cool. Let me stop the stream. And thank everybody online for joining us. Let's see.